method, we can easily solve the shortest path problem. However, for complicated graphs, we cannot easily draw the maps automatically using command like this, or the maps drawn may not be very good to read. And also, if you do not have the bioinformatics toolbox installed on your computer, you have to solve the problem with low-level commands or use a certain algorithm. For instance, there is a very famous algorithm, the extra algorithm, which can be used to solve the problem. And based on that, I write a piece of code. And this code can be used to solve the shortest path problem. However, there is no graphical display of the result. And the syntax in the command is exactly the same as the one I used earlier. And the W here is the R matrix we defined. And this is the starting node S, and this is the end node T, target node. And by calling this function, we get the shortest path and also the sequence of nodes in path variable. We can solve the problem again. However, with the use of this algorithm or this function, there is no graphical display of the results. Now, in this chapter, we talked something about the solution of nonlinear equations. Well, three methods basically we have discussed. One is by graphical method, and the other one is by symbolic method, and also the one with numerical solution method, numerical solutions. And also we talked about the solutions of nonlinear matrix equations. So these parts are almost equation solution problems. And apart from it are the optimization problems. We first discussed the unconstrained optimization problems. And then we talked about the linear programming problem, quadratic programming problem, and ordinary nonlinear programming problems. And we also extended the idea into integer programming problems or mixed integer programming problems. And also the binary programming problems. We can solve this kind of problems easily. And also we talked something. We used an example to demonstrate the use of shortest path problem solutions. Now that's all for this part. So now let's start another chapter on another mathematics branch, differential equation problems. And I think you have done a lot of simulation of systems, and continuous systems are usually described by differential equations. So now the problem is, how can we solve differential equations with Matlab? And in this chapter, I will talk about the following topics. One is how to find the analytical solution to certain differential equations. And the other one is how can we find numerical solutions to differential equations, ordinary differential equations. And then, for some special form of ordinary differential equation, such as differential algebraic equation, delayed differential equation, how can we solve those kind of differential equations? And another topic is how can we solve boundary value problems? And also I will give a short demonstration on how can we solve partial differential equations using Matlab functions. And finally, I will describe about how can we use block diagram method to solve differential equations, because this one is particularly useful in control system simulation. So I will demonstrate this part with the use of Simulink. How can we solve differential equations using Simulink? So let's start with the first topic. How can we find the analytical solution to a given ordinary differential equation? And in this part, I will concentrate on the use of Matlab functions rather than mathematical details here. Suppose there is a linear ordinary differential equation. We know from calculus course that you can map this one into an algebraic equation, and where we can find all the eigenvalues in the roots of the algebraic equation. Then we can write out the final analytical solution to the original differential equation. And it is something like this. We have to find all the roots and then compose the final analytical solution to the original problem. I'm not quite sure whether you still can recall this kind of mathematical details. So I'm not going to talk too much about it now. What I want to talk is how to use a Matlab function to solve this differential equation directly. And in algebraic equation solutions, we introduce a function called solve, where you have to code all the equations one by one and then code the solve function, find the algebraic equation to them. And for ordinary differential equation, what we need is to call a solve command. And we can also code all the equations one by one and then we can solve it. However, it should be noted that the independent variables used in this function call must be t. It cannot be any other variable. It must be t. If the equation which has the independent variable other than t, suppose it is x, then we have to use this syntax to indicate that the independent variable is x. So we have to be very careful with it. If you use a wrong argument here, you describe the wrong independent variable here, wrong result might be obtained. So we must be very careful here to choose the independent variable. If it is already t, then we can omit it. Otherwise, we have to declare it here.